So now we're going to talk about Poisson's distribution. It's called Poisson's. Right. So there's two main characteristics of Poisson's. The Poisson's probability distribution gives you the probability of a number of events occurring in a fixed interval over time and space if you know the event's average rate and independently of the time since the last event. For example, a book editor might be interested in the number of words spelled incorrectly in a particular book. It might be that on average there are 5 words spelled incorrectly in 100 pages. So the interval is 100 pages. I did this in my master's program. I did it for whale sharks. I wanted to know for whale shark season, what was the average number of whale sharks you could see. So we had looked at like the average rate of like a day, or I think we did like a month. We looked at a month of like the average number of whale shark sightings we saw a month. And then we looked at it over a 3-month period, and we used the Poisson's distribution to see where you could predict of seeing whale sharks. All right, so the Poisson's distribution may be used to approximate the binomial if the probability of success is small, such as 0.01, and the number of trials is large, such as 1,000. You will verify the relationship and the homework assignments, and I'm not going to trick you on these homework assignments or even the test. You're going to have time. It's going to be talking about time, and then you have to look and see what's going on in that time. So N is the number of trials, and P is the probability of success. All right. So the random variable X is the number of occurrences in the interval of interest. So the way to write this one is the distribution approximates Poisson's for the mean, where the mean should be given or calculated by finding the average. All right, so let's do our first example. This is going to be tricky, but I think once you kind of get it, it'll click. So Lee's cell phone receives about 6 telephone calls between 8 a.m. and 10 a.m. What is the probability that Lee receives receives more than, I said that wrong, I'm so sorry. What is the probability that Lee receives more than 1 call in the next 15 minutes? All right, so the next 15 minutes is my time, but that's just the small part of the time, because remember, she receives 6 telephone calls between 8 a.m. and 10 a.m. All right. So let X be the number of calls Leah receives in 15 minutes, because that's what I'm testing. So it's 15 minutes or 1/4 of an hour. So X is 0, 1, 2, or 3. So that's the number of calls again. All right. So if Leah receives on average 6 telephone calls in 2 hours, and there are 8 15-minute intervals in those 2 hours, then Leah receives, so it's 1/8 times 6 equals 0.75 calls in every 15 minutes on average. Okay, so the mean is 0.75 for this problem. Like, I know you can't receive 0.75 of a phone call, but we're taking the average. So this distribution approximates the Poisson's with 0.75. Okay, so now we know that. We know our average is 0.75. Okay, and how did we figure that? We did the overall time times the number of calls. All right, so now we want to know that we get more than 1 call per hour. All right, so then we're going to use Minitab. And again, I have all the directions here that you need to do. And when you look at it, go ahead and do what you need to do to find it, okay? All right, so let's go ahead and do this one. Okay, I'm going to go here. Let's do this one. I'm going to do Poisson. Let's do calls, and then I'm going to do calls prob. Okay. So here I go. I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Because it tells me here what I need to do. Oops. I'm sorry. I need to go to 6 because I only got 6 phone calls. Okay. Oop, I hate when it does that. Okay. All right. So now what I need to do is go to calculation, probability, Poisson's. And there it is. Okay. So I'm going to do cumulative probability. Remember, I said the mean was 0.75. My input column is calls. My optional storage is calls prob. And then I hit OK. All right. So Now that I'm going to look and see, okay, so here are my answers. I'm going to scroll up so you can see the 0. Okay, so what I have here is the same as what I have on the on the PowerPoint. All right, so more than one. All right, let's go back to this for a second, and I want to make sure that we're really understanding what we're seeing. I'm going to make it bigger. Okay, for these calls, for 0 calls, it's 0.47. For 1 and 0 calls, it's 0.82664. For 0, 1, and 2 calls is 0.959495. Okay, so what's going on? Remember, because I used, I'm going to go back to the calculator and show you, because I used the cumulative probability, cumulative means that it's taken the ones before it and adding it onto that number. That's why it's really important. So I wanted to know more than one call. Okay, so more than one call, I've got to do some math here. So what I need to do is, all right, I need to look one where I get 0.826641, but I need to subtract that from 1. So if I do that, I get 0.173359. So the probability that Leah receives more than one call in the next 15 minutes is 0.1734. All right, let me show you something else. Okay, so I'm going to change this name a little bit. I'm going to put this cumulative prob. Okay, so let's do, if I did call just prob. Okay, all right, so I'm going to do this. I'm going to go back up here and I'm going to show you the difference, just so if it's not making sense, it'll make sense. Prob. I'm going to change this to be, okay, and if you see here, this is what's going on. So I'm looking for 1, remember, and it said more than 1. So I would add these 2 up, which is the same as this right here. Okay, that's all that's going on. This, remember, adds them up as it goes up. This is the individual. This is the probability you'll get 0 calls, the probability you get 1 call, the probability you get 2 call, the probability you get 3 call. That's the only difference in these. Again, cumulative probability adds it up as it keeps going. Probability just takes it one at a time. All right, so we did that one. Okay, so then we finished that one. So let's look at example 2. All right, at night, Lee gets more calls. Her cell phone receives about 12 telephone calls between 6 p.m. and 9 p.m. What is the probability that Lee receives exactly 3 calls in the next 30 minutes? All right, this one's different. Why is this one different? So my time interval changed and the number of calls I was looking at changed. All right, so let X be the number of calls Lee receives in 30 minutes. The interval of interest is 30 minutes or a half an hour. Remember, for the previous one, it was 15 minutes. I just changed it. The X is 0, 1, 2, and 3. Okay, so now remember, I got to find my mean. So if she gets 12 telephone calls within 3 hours, and there are 6 30-minute intervals, so it's 1/6 times 12 gives me 2 calls per, oops, that shouldn't be that long, 30 minutes. So my average is 2 calls per 30 minutes, okay? So the distribution approximates Poisson's, and it's 2, okay? All right, so now what is the probability she gets exactly 3 calls? All right, so let's go here. I'm going to do a new one. I'm going to do night calls. Okay, I know you're like, why do you keep changing them? Just so I can go back and look at them. And I'm going to do night call prob. Okay, so I'm going to do 0, 1, 2, 3. Remember, because I wanted to know that she gets exactly 3 calls, and then I've got to do through 12. Remember, I'm sorry. Why do I have to do 12? Because she received about 12 phone calls. Okay, again, and I know this gets taxing having to put all the numbers in here, but I promise it'll get easier. 8, 9, 10, 11, and 12. Okay, so I've got my 12. I'm going to make this bigger since we don't have anything going on in the window, the upper window. Okay, so I'm going to do that, and I'm going to scroll back up. Okay, 0 through 12. Again, I'm going to go to Calc, Probability Distributions. I'm going to go to Poisson's. I'm going to do probability. My mean is 2 now, and I'm going to change where I'm going, getting this. This is going to be night calls, and this is going to be night call probability. Hit OK. All right. So remember, because I did just straight probability, I'm going to go look at 3. Okay. Don't look at these over here. Look at here, because this is where you did it. So for the probability you get exactly 3 calls is 0.180447. So here's your directions again. And if I go in there, yep, there it is. The probability that Lee receives exactly 3 calls in the next 30 minutes is 0.1804. And that's how you do Poissons. And again, you're looking for, there's some kind of time limit or time interval, and then there's something going on in that interval that you can measure.